Good morning all, my name is Matthew Yates and I'm from Central Queensland University in Rockhampton in Australia. Today we'll be examining the relationship between isokinetic quadricep to hamstring strength ratio and time to stabilization on dominant leg jumps. Balance is commonly referred to as stabilization, and it can be investigated further to specify time to stabilization. An efficient time to stabilization, or balance, is a fundamental movement required to successfully perform majority of sports. Balance allows an athlete to begin a secondary movement, such as jumping, running, or coordinating other limbs. This skill is advantageous for performance and is beneficial to avoid lower limb injury. Previous research has found that if eccentric quadricep contraction is great enough, the ACL may be at risk. Isokinetic strength measures serve as a useful tool to identify this quadricep hamstring strength ratio. For this study, a bidex dynamometer will be used. The purpose of this study is to further examine this relationship between isokinetic quadricep to hamstring strength ratio and its time to stabilization. All experiments will be conducted on dominant leg jumps. A relationship could provide further insight into how individuals can improve quadricep to hamstring strength ratio if it has a relationship with improving stabilization. As previously stated, this will be applicable to the vast majority of sports, as well as human movements in general. The research hypothesis is that an even quadricep to hamstring strength ratio will result in a faster time to stabilization. For the methods, we had 11 participants used for this study, 5 males and 6 females. They varied in age, height, weight, and level of physical activity. All participants were free from lower limb injury, meaning ankle and knee injuries, and ethics and CQU approved consent forms had been completed prior to any testing. We can have a look at Table 1 for a closer detail of the demographic data. So the mean age was 29.8, the stature was 164.8, the body mass was 74.9, and the overall BMI for all participants was 30.6. For the procedure, all data was recorded during one single testing session. Participants were tested on two main things, being dynamic balance and then isokinetic quadricep hamstring strength ratio. The dynamic balance was completed on a force plate used in the CQU lab, and the strength ratio recorded on the bidex dynamometer, also in the CQU lab. To begin the testing, a warm-up was conducted. Participants walked at 5.5 kilometers an hour at a 4% incline for 5 minutes, and that was completed on the Landis cardio trainer in the CQU lab. For the dynamic balance, participants jumped from outside and then onto the force plate, once again all using their dominant legs. They completed 2 jumps from the lateral side and 2 jumps from the medial side, totaling 4 jumps all up. Each jump had to be held for 10 seconds after landing. The jump positions were measured from the center of the force plate outwards, so we can see that detail in figure 1. So from the center of the force plate, a distance was measured on a 45-degree angle to either side, and that measurement was 60% of the person's leg length. For each jump, a minimum of 1 and a maximum of 3 practice jumps were allowed. The hands had to remain on hips for the entire trial, and the non-dominant leg was to be bent at 90 degrees at the knee, and participants had to focus on a mark marked out on the wall in front of them. For the isokinetic strength ratio, the major focus was on preparation of the biodex and the participant's positioning. You must ensure the participant was seated correctly, strapped in with arms across their chest, and more importantly that the knee aligns with the shaft axis of the biodex. We set the range of movements from 90-degree flex to 20-degree flex, enabling the total range of movement to be 70 degrees. Then we applied the gravity correction. Most importantly, inform the participants of the procedures and what to expect, which was broken down into Protocol 1 and Protocol 2. Protocol 1 was the quadriceps, so we did concentric and eccentric torque. That was measured at 60 degrees per second and 180 degrees per second. And then Protocol 2 was specifically the hamstrings, which is when we had concentric and eccentric torque. That was measured at 60 degrees per second and 180 degrees per second. For the statistical analysis, an alpha level of P 0.05 was established to determine statistical significance. For the testing conducted, a paired t-test was used on the overall time to stabilization and the strength ratio data. All statistical analysis was conducted using Microsoft Excel Data Analysis Toolpack. To the results. Results show there is no significant relationship between isokinetic quadricep to hamstring strength ratio and a better time to stabilization. This did not support our initial research hypothesis that an even quad-ham strength ratio would result in a faster time to stabilization. Figure 1 provides a further detail of these results. So looking at the mouse here, we can see that our results fall in this general range up here. It can be seen that a strength ratio roughly possessed was about 1.6 or 1.8, aligning with majority of the participants there, and it took about 3.5 to 4 seconds to stabilize. So our research hypothesis assumed that data would have fallen somewhere around this range here, meaning that the strength ratio would be closer to 1, therefore more even, and therefore lining up with a faster time to stabilization. However, that's the results that were found. Research in 1991 states that an isokinetic quadricep to hamstring, which is eccentric to concentric, strength ratio greater than 1.33 at 180 degrees per second, athletes are 1.6 times more likely to sustain a lower limb injury. This study was conducted in females. While this study identifies that any ratio above 1.33 may provide less ability for potential or injury, our research finding states that all females possessed a strength ratio greater than this 1.33 at 180 degrees per second. These findings may lead to further research on female lower limb strength and injury. Further studies in 2008 state that if eccentric quadriceps contraction is great enough, the hamstring cannot provide a counterforce, then the knee joint becomes at risk. Similarities can be drawn between this study and the results found, in that all participants possess much greater quadriceps strength than hamstring strength. Further research may be conducted to assess if these subjects are potentially at risk of lower limb injury. Overall, a lot of interesting research was found regarding the quadricep to hamstring strength ratio. With the CQU facilities, we could recreate our own study. The study took place at the CQU Rockhampton campus using all 11 participants. They were tested on strength ratio and dynamic balance being the two main testers. All participants conducted themselves safely in the laboratory, and I thank all participants for their effort. In conclusion, although the hypothesis was rejected, I believe the study had a strong purpose, and I believe valuable information can still be taken away. Practical implications of this study: it's emphasized the importance of the quadricep hamstring strength ratio. It also sheds light on the fact that the even strength between these two lower larger limb muscle groups, the quadriceps and hamstrings, is desired. These muscle groups can be specifically targeted in training programs, therefore to try and improve stabilization or balance in sport, and obviously to avoid lower limb injury. Balance is a fundamental skill for the vast majority of sports and general human movement. These muscle groups and strength ratios should also be targeted in training programs in regards to injury. The quadricep to hamstring strength ratio should be a guideline for preventative and repair injuries. For senior and semi-professional sporting teams, it should be vital to access a dynamometer to determine this strength ratio for athletes' performance and general well-being. And please find attached the references as well. Thanks very much for listening.